Hello and welcome to Engineer's Mindset. So in today's video, we are going to be looking at the difference between static friction and kinetic friction. But let's understand, what is friction? Friction can simply be defined as the force which acts to oppose the motion of an object. So take a look at it as a 10 newtons force which is actually applied to pull a 50 kg mass to the right. Now, this is going to be very impossible because the 50 kg mass contains approximately 500 newtons weight, which is enough to offer resistance to the 10 newtons force. So that simply means that this mass will remain at that position because the force applied is less than the weight of the object. Now, that brings us to the idea of static and kinetic friction. Since the applied force is less than the weight of the object, it means that this object will remain at one position. That one position is called the state of rest, which is also called statics. So what then is static friction? Static friction is simply the frictional force which is applied to oppose the motion of an object and causing that object to remain at rest. In most cases, the weight of an object is responsible for static friction. If the weight of an object is greater than the applied force on the object, it means the object cannot move, rather remains in one position, and the frictional force offered in this situation is called the static friction. Okay, usually represented as what? Fx, where x indicates statics and F for friction. Now, it is important for you to know that friction cannot take place without two surfaces coming in contact. So for friction to take place, there must be a contact between two surfaces, which is why you have this mass resting on this surface. As such, whenever two surfaces comes in contact, there's always what is called a normal reaction between the two surfaces in contact. And this normal reaction is always directed at 90 degrees or perpendicular to the surface where it is acting. So for this case now, where we have the mass of 50 kg resting on this surface, then we have a normal reaction which is always at 90 degrees to the surface of occurrence. So it must be perpendicular to this surface, and this normal reaction is denoted by N. Most textbooks use R to represent normal reaction, and most textbooks use N to represent normal reaction. So we are going to be sticking with N as our normal reaction. So the normal reaction force is always directed at 90 degrees to the surface of occurrence or the surface of contact between the two objects. Now, the static frictional force is always directly proportional to the normal reaction force. The static frictional force is always directly proportional to the normal reaction force. So you simply have Fs, which is the static frictional force, is directly proportional to the normal reaction force. And you know, whenever you remove a proportionality sign, you always introduce a constant. So this simply implies that our static frictional force Fs is equal to the constant, in this case is called μs multiplied by n. Now this μs simply means the coefficient of static friction, where μx means the coefficient of static friction. So static frictional force can simply be given as the coefficient of static friction multiplied by the normal reaction or normal reaction force. So in this case now, if I want to make the coefficient of static friction subject of the formula, this simply means μs becomes the static frictional force divided by the normal reaction force. So you keep this equation aside. So this is how you find the coefficient of static friction. Simply the frictional force divided by the normal reaction force. Now, what happens when the effort or the force applied on the object is enough to move the object? For instance, in this case, I have a 100 newtons force pulling a 3 kg mass to the right. A 3 kg mass invariably has approximately 30 newtons weight. So which means the weight of this object is not enough to resist the 100 newtons force applied on it. As such, this object will be caused to move where? To the right, which is the direction of motion. This object will be forced to move to the right. Now, always frictional force acts to oppose the motion of an object. So even while objects are in motion, they are still experiencing frictional force. So while this object is in motion, it is experiencing a frictional force which is acting against the motion of that object, believing and hoping that a point will come when the object will come to rest, and all thanks to what? The frictional force. In this case, when the object is in motion, the frictional force exerted is called the kinetic frictional force. The kinetic frictional force is simply the force which is applied to an object in motion to oppose the motion of that object. So while the object is experiencing motion, there is still frictional force acting on the object. And always, whenever two surfaces comes in contact, we always have what is called a normal reaction. Since this 3 kg mass is resting on this surface, then we have a normal reaction which always acts at 90 degrees to the surface. It always acts at 90 degrees, as can be seen here. This is 90 degrees or perpendicular to the surface, which is why it is called a normal reaction. And the kinetic frictional force, just like in the static frictional force, the kinetic frictional force is also directly proportional to the normal reaction force. So you simply have that Fk, now in this case now, Fk, K for what? Kinetics, which means the frictional force applied when an object is in motion. So Fk is directly proportional to the normal reaction. And you know that whenever we remove a proportionality sign, we always introduce a constant. Now, Fk is simply equal to mu k multiplied by n, where mu k is simply called the coefficient of kinetic friction and not static. So static has to do with when the object is at rest, whereas kinetic has to do with when the object is in motion. So if we make the coefficient of kinetic friction subject to the formula, you're going to find out that mu k is equal to the kinetic frictional force itself divided by the normal reaction. And you simply have this. Just like in the static frictional force, they all have the same formulas, only that one is applied when the object is at rest and the other is applied when the object is in motion. Now, I mentioned that there cannot be friction without two surfaces coming in contact. That is simply in solids, right? Now, if we have the motion of an object in air, in that case, two surfaces are also coming in contact but unseen, because the motion of the object is in contact with the air. Now, in this case, friction is simply called viscosity and not friction. So when it comes to solid, whenever two surfaces comes in contact, there is always bound to be a friction. There is always bound to be a friction. But when it comes to liquid or fluid, the two surfaces in contact, also there is a friction, but that friction is called viscosity when it comes to fluids. Now, there are 3 key things that tells us whether an object is exhibiting a static friction or kinetic friction. The first thing is if the applied force on the object is less than the frictional force. Now, let's simply say P is the applied force. Let's use P as the applied force. If the applied force is less than the frictional force, then we simply say the object will remain at rest. So if P, which is the applied force, is less than the frictional force, then this object remains at rest. This is called statics. The object will remain at rest if the applied force is less than the frictional force. Let's use Fr for frictional force. If the applied force is less than the frictional force, then the object will remain at rest. That can be seen over here. Okay, I have a 10 newtons force trying to pull a 50 kg mass, which is very impossible. So this object remains at rest. The second thing to know is that if the applied force is equal to the frictional force, in this same case, the object also remains at rest. This is also called statics, which means the friction exhibited here is called a static friction. So 2 things: when the force applied is less than the frictional force, we have what is called the static friction. When the force applied is equal to the frictional force, we also have what is called the static friction. And finally, when the force applied is greater than the frictional force, then the object is in motion. Then this is simply called kinetic friction. When the force applied becomes greater than the frictional force, then the object is set in motion in the direction of that force applied. And as such, the friction that takes place there becomes kinetic friction. It is important for you to know that the frictional force and the normal reaction force are always at 90 degrees to one another. So we are going to be plotting this here. So as can be seen on the board, this is the normal reaction line, which always is at 90 degrees to the surface, and in this case is vertical. So we have it here purely vertical, and then we'll have the frictional force which opposes the motion. This is the frictional force, like this. All right, the two of them are always at 90 degrees to one another. We are going to see more of this when we come to inclined plane friction. Now, it is also important for you to know that the angle between the incline and the normal reaction is always taken as the angle of inclination. The angle between the incline and any vertical line at all, not necessarily a normal reaction, but the angle between an incline and any vertical line at all is simply the angle of inclination. We'll do more of that when we come to inclined plane friction. So I have my vertical line here to be the normal reaction, and this is my incline. The angle between these two is always taken as the angle of inclination, theta. And if we take the tangent of this angle, tan theta, we are going to find something that tan theta is equal to opposite all over adjacent, and opposite is the frictional force and adjacent is the normal reaction force. So we simply have opposite is the frictional force all over normal reaction force. So this simply implies that if the frictional force is a kinetic frictional force, then tan theta, okay, is going to be equal to what? The kinetic frictional force Fk divided by the normal reaction. And as can be seen here, mu k simply means Fk all over normal reaction. This simply implies that in place of Fk over normal reaction, that is our coefficient of kinetic friction. As such, the coefficient of kinetic friction can also be taken simply as what? Tan, or the tangent of the angle of inclination. So this is another formula for the coefficient of kinetic friction. If you're given an angle of inclination, then the coefficient of kinetic friction is simply the tangent of that angle. Same thing is applicable to the statics. If the frictional force is a static frictional force, that simply means that tan theta, okay, is going to be equal to the static frictional force all over normal reaction. And as can be seen here, the coefficient of static frictional force is simply what? The static frictional force divided by the normal reaction force. So which means the whole of this is simply what? Mu s, which is the coefficient of static frictional force. Okay, so this simply implies that mu s also is simply equal to tan of the angle of inclination. So that's another way to find the coefficient of static friction. All right guys, so in all, that is the basic idea or difference between the static friction and the kinetic friction. In the next video, we are going to be looking at the static friction and kinetic friction on an inclined plane. I hope you find this video very interesting and helpful. Please, if you do, I would like you to show me that by liking these videos, commenting nicely, sharing to your friends, and if you're new to the channel, do well to also subscribe. I will see you in the next video. Thanks.